So this is a presentation on our approach to bulk DDI study level metadata validation. So first, a very quick introduction for those of you who may not be familiar with CESSDA. So CESSDA is the consortium of European social science data archives. It's a European research infrastructure consortium, otherwise known as an ERIC. We have 22 members and 1 observer, and these members of them are various research institutions, mostly data archives. And throughout this, they cover many different European languages and countries. And some of these archives have a huge amount of history behind them. Some of them are very new. And through this, CESSDA offers a common face and acts as the social sciences gateway to the European Open Science Cloud. So a quick introduction to the CESSDA data catalog, if you haven't heard of it. So its goal is to collect all metadata records of all data holdings at the various national service providers and store them in a common place. We use DDI codebook as a common metadata format for study level records, and we implement this in the CESSDA metadata model. We currently have 33,000 records, which is quite a lot. And this is all displayed through a central search interface, of which a screenshot is in this slide. But through the data catalog, the data is further indexed by Google Dataset Search since about 2018. And from 2022, there will be an OII PMH endpoint following the creation and specification of the CESSDA data catalog aggregator. So let's dive into the problem of it. Why do we need validation at all? And what's the problem of this bulk trying to address? So we have, so our service providers generate study level metadata in DDI format. And for each of these records, we need to ask a couple of questions. So per record, we want to basically ask 2 questions. Is it well formed? And by that, we mean, is it valid DDI? Are there questions that prevent it from being parsed correctly? And the other question that we ask is it complete? Are all the expected values that we expect to be as part of the CESSDA metadata model, are they all present? As in, does it have an abstract? Are the titles in? Does it have authors? And this is for all sources of the data catalog. So we're trying to ensure consistent quality across these 33,000 records. So what's the story so far? We have, we've introduced a tool called the CESSDA Metadata Validator, which is a tool that can be used to validate individual metadata records. Using what's known as profiles, you can validate a metadata record, and these profiles define various constraints within them. And these constraints are described by semantic definition as well as XML representation and example usage. And these constraints are assigned to 5 predefined validation gates of varying different levels of strictness. They go from basic, which is the least strict, to strict, which is very strict. Supporting this is the CESSDA Metadata Office, which is responsible for the CESSDA metadata portfolio. So the CESSDA Metadata Office is responsible for creating the CESSDA metadata model, which is the internal representation that's used by the data catalog. And it defines the attributes used to represent study level metadata and whether they're mandatory or optional. Supporting this is what's known as CESSDA controlled vocabularies, which are centrally agreed standards of certain data, such as the publisher names, so the names of the organizations providing metadata, the CESSDA persistent identifier types, which is what persistent identifier forms are acceptable for inclusion in the data catalog. So, and topic classification, which is common topics that can be used for sorting and aggregating purposes. And finally, country names and codes, which is mostly just standard ISO 2-letter codes. They're responsible for creating the DDI profiles that are used by the metadata validator, and they're also responsible for the European Language Social Science Thesaurus content, which can be used to access data independent of the main resource language of vocabulary, and ELST is available in 14 different languages. They also are responsible for reporting metadata issues to service providers and tracking progress to their resolution. So the CESSDA Metadata Validator has a very easy to use user interface where you select the validation gates, the validation profile used, of which there are predefined profiles, which are the standard profiles. But you could also upload your own profile if you wanted a custom validation. And documents can be uploaded either by supplying a URL or by uploading a document. And the results are then displayed in a table below. The problem with this interface is that it essentially only works on one file at a time, which is fine if you want to validate the metadata that you've just been working on. But if you have 33,000 records, it becomes a never-ending task. Here's an example of the various validator gates. As you can see, as you go from left to right, from basic to standard, extended, and strict, there are various, there are more constraints that are enforced as you go further down. Strict is very strict. And the idea is this acts as a common target for service providers to aim for. So we can gradually increase the threshold over time and gradually bring up the quality of the metadata from our various service providers. So here's an example of one of the profiles that is used for validation. This is a HTML rendering of the profile itself. So you have the XPath to the element. We have whether it's mandatory, optional, or recommended. We also have a column for the UI label, which is the under the data catalog user interface. It's what it will appear under. We have the type of data, so whether it's an attribute or an element, and if it is an element, there's a note of whether you can repeat this element or not. And then finally, there are some usage notes that give some information of how you're supposed to use these XML. So this is a relatively simple profile. It has been shrunk to fit on this slide. So what if you need to validate 33,000 records? Well, here's where the bulk validation pipeline comes in. So we start on the left. We have the various repositories which offer metadata in a variety of different formats. The current accepted formats are DDI 1.2.2, but it's NESTAR flavored DDI. Most repositories offer DDI 2.5 metadata, so those repositories based on Dataverse, Kuha2, and some others. And we also are able to harvest DDI 3.2 metadata. And this is all harvested by a central harvester. Once it's harvested, the metadata is then validated. There are 3 types of validation checks. One, schema validation. then metadata validation, and then we check the persistent identifiers. And the records that are rejected are dropped at this stage and are not stored. The records that pass are stored and then are consumed by downstream components, which includes the data catalog user interface, the data catalog aggregator endpoint, as well as the European question bank. So to summarize, we have a central harvester for both the data catalog and the question bank, which harvests metadata of service provider studies, which includes things like study description, authors, collection period, and more. These are harvested from OAI PMH endpoints, and these records come in an OAI PMH envelope with DDI metadata embedded underneath. And the harvester can remove this OAI PMH envelope, and both versions are stored. This is required because the validator itself does not want the OAI PMH envelope. And this is harvested to a Google Cloud storage bucket, which if you're familiar with Google Drive, or perhaps more closely with Amazon S3, it's equivalent to that. Then all VAT records are validated using the metadata validator, and records that passed are marked as valid. And these valid records are then ingested by downstream components. So this pipeline allows us to filter data from the source repositories to the various downstream components, and we can assure that everything that ends up on the user interface and everything that's then re-exposed in the aggregator is of our standards. But we need to have a dashboard to view. We need to have a dashboard to view cases where things fail validation, so we can send reports off to service providers. And here's an example of the dashboard. So we have the first dashboard mentions XML schema violations. These are things that mean that the document being validated is not valid DDI. And there are 3 columns: the repository name, which is where the record came from, the OAI record identifier, and with these 2 things, we can uniquely identify which record and which repository it came from. And then in the 3rd column is a list of schema violations that were found. The output for the CESSDA metadata validator constraint violations is very similar. It just has 2 extra columns. One is the profile name, which is a link to the profile that was used for validation, and the second is the validation gate that was used. So what are the outcomes in this? So the idea of this is we can use this to improve the quality of study level metadata generated by CESSDA service providers and made available to users via the data catalog, checking for well-formedness using XSD validation and completeness using the metadata validator validation and checking persistent identifiers. And throughout the bulk and using the bulk validation pipeline, we can get consistency because this checks everything and it checks it often. So in conclusion, the bulk validation pipeline allows us to easily find 2 types of errors. One is systematic errors. This is a mistake that may be common to a large portion of records. So you may have for a certain repository, they're all missing an element that's required. And this can be used to find bugs in implementations, as well as other mistakes that are made. And because it's bulk, you can easily see the pattern in the data. But the other thing it allows us to find is one-off errors. So if you have a repository with, say, 5,000 records and only a couple of them have problems, you're not going to find that unless you do a bulk validation run if you don't know where the problems are, or if you're not aware that you have them. They're 5,000 records. You're not going to have time to feed them in individually. So this allows us to find these needle in the haystack issues as well. But we're thinking of extending this work further. One of the things we're working on at the moment is extending this bulk validation pipeline to potentially check for fairness using, for example, Fuji for bulk assessment. And we're currently doing work on the data catalog itself in order so it exposed the necessary information in order to perform this validation. And as well as this, the aggregator has been mentioned several times already, but this is still work in progress. And the idea is the metadata exposed by this aggregator is of an ensured quality, and for more information on that, there is a presentation happening today, which you can check the video on demand later. Okay, thanks for listening.